Okay, for this lesson, we're going to learn how to convert numbers that are written in standard form, which just means the form that we're used to using, into scientific notation. Then we'll also be able to convert scientific notation into numbers in standard form. So scientific notation is shorthand to write very large or very small numbers. So in our first example, we have 58 million, and we can write it in scientific as 5.8 times 10 to the 7th. You can see that we have another very large number, and we can write it using the power of 10. Then we have very small numbers, and we can write these in scientific using the power of 10 as well. So this value, 58 million, is equivalent or the same as 5.8 times 10 to the power of 7 and vice versa. So each of these represents the same number, the same value. They are equal to each other. So let's talk about the parts of scientific notation. The first part is called our coefficient. Notice that the decimal is one place after one digit. So in this place, in the ones place, we have a number. So the decimal has to go one place past this ones position. So we have 9.72. Then we are always going to be multiplying by a base of 10 raised to some exponent. So let's go over this again. This part is the coefficient, and the value has to be between 1 and 10 and cannot be 10 or more. So you can see 9.72 is from 1 to 10, but it can't be past 10. That's very important. And then it's going to be times the power of 10. So this scientific notation is actually this number, 972,000, and this is standard form, the form that we are used to seeing numbers. So we're going to convert scientific to standard and standard to scientific. One thing to note is 972,000 is a very large number, and our exponent on the base of 10 is positive. So when we have a positive exponent, we're looking at a very large number, but when we have a negative exponent, we're used to writing it as a fraction, but this time we're going to write it as a very small decimal. So let's practice these. Remember, at any time you need to pause the video to take good notes, please do so. So here we have 21,300,000. We're going to write it in scientific. So we need to make our coefficient a number between 1 and 10, but not greater than 10. So the decimal needs to be right here. So we're going to say the coefficient is going to be 2.13, and the goal is to write as little as possible in our coefficient, so we don't need any of these zeros. Then it's going to be times 10, and this is one time that we use the x for multiplication is in scientific notation. Now we have to establish the exponent. So the original decimal was at the end, and we moved it 1, 2, 3, 4, 5, 6, 7. So it's positive 7. Our next example, we have a very small number, and the coefficient, the beginning part of our scientific, needs to be a number between 1 and 10, not including 10. So the decimal needs to be moved to here, and our coefficient is 5.8 times to the power of 10, and we moved it to the right, 1, 2, 3, 4, 5, 6, and we say -6. So when we move it to the right, when we have a very small number, we have a negative exponent indicating a small number. Okay, here we have 760,100,000,000. Our decimal needs to go right here. It starts out here, when it's not written, we know it's at the very end. So our coefficient is 7.601. So you write all the digits until all you have left is zeros. Times 10, and we're moving our decimal to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we have a positive 11 because we moved it left because this is a very very large number. In our last example, we need a coefficient between 1 and 10, not including 10, so that means the decimal needs to go right here. 8.37 is between 1 and 10. So 8.37 is our coefficient times 10. And I know this is a small number and I'm moving my decimal to the right, so it's going to be negative. So we moved it 1, 2, 3, 4. So -4. Now just let me warn you, this exponent is not how many zeros there are. That is not what this means. This value tells me which direction I moved the decimal and how many times I moved it to get it so that my coefficient is between 1 and 10, not including 10. So we have a single digit to the left of the decimal. Okay, pause the video and you try these. Okay, number 1, we have 2.9 times 10 to the negative 1, 2, 3, 4, 5, 6. Number 2, we need the decimal to go from here to here. So 8.4 is our coefficient times 10 to the 1, 2, 3, 4, 5, 6. Number 3, 1, 2, 3, 4. So we have to move it behind, and that's going to be -4. Number 4 is 2.4 times 10. 1, 2, 3, 4, 5 to the positive 5. Number 5, the decimal needs to be moved to there, 6.43 times 10 to the negative 1, 2, 3, 4, 5. And the last one, the decimal needs to go from here and move all the way up to here, and our coefficient is 9.99 times 10 to the positive 1, 2, 3, 4, 5, 6, 7. So make sure you correct any mistakes that you made. Okay, now we're going to go from scientific to standard. So we're going to be moving the decimal how many ever times our exponent is. If it is a positive, we're going to create a very large number, so we'll be moving the decimal to the right. If it's a negative exponent, this number is going to be very small, so we have to move it forward. So we have 8, 5, 1. So I'm going to move the decimal 1, 2, 3, 4, 5, 6. So I moved it 1, 2, and I had to add some zeros, and now my decimal's at the end. Now we have 8.51 times 10 to the negative 6. So I'm going to write 851. My decimal is here, and I have to move it to the left this time. So I move it 1, 2, 3, 4, 5, 6. And then if you like to put an extra little zero out front, that is fine. So I moved it 1, 2, 3, 4, 5, and 6. The next one we have 2, 0, 1, 1. So I moved it 1, 2, 3, 4, 5. So this is again how many times we move the decimal. This time we're going to have a very small number, so we're going to move the decimal to the left. It started here behind the 2, and I move it forward or to the left 1, 2, 3, 4, 5. And then you can put a 0 out front. Okay, pause the video and you try these. Okay, on number 1, our decimal is going to be moved to the left because we're creating a small number. And I'm moving it 1, 2, 3, 4 decimal. Here we have a positive exponent, so we're going to be making a very large number, so we're going to move the decimal to the right. So I'm going to move it 1, 2, 3, 4, 5. And again, the exponent does not indicate how many zeros you have. It's how many times you move your decimal. Number 3, we're going to make a very small number, so we're going to move the decimal, which is behind the 2. So when there's no decimal, it's understood to be at the very behind to the right. So I'm going to move it 1, 2, 3, 4, 5, 6, and the decimal. And the last one, we have a positive exponent, so we're going to move our decimal to the right, making a very large number. So you don't have to really remember which way to move the decimal. You just know, am I making a large number or a small number? So we have 6, 4, 1, 3. So we moved it 1, 2, 3, 4, 5, 6, 7. So make any corrections of the ones you got wrong. Now we're going to compare. So we could compare if we have two different bases of 10, and we know 10 to the 4th, okay, is smaller than 10 to the 5th, or you could just go ahead and write this out. So 8.51, and I'm going to move it 1, 2, 3, 4. And then I have 6.3 times 10 to the 5th, so 6 and a 3, so I'm going to move it 1, 2, 3, 4, 5. And you can see that 85,100 is less than 630,000. But I got already compared it just by looking at the powers, but sometimes our powers may be the same. And here when we have negative, so let's work this one out. So we're going to convert this to standard. I'm going to move it 1, 2, 3, 4. And then here we have 6.3 times 10 to the negative 5th. So I'm going to have 6. So I'm going to move the decimal 1, 2, 3, 4, 5. So when we compare decimals, it's good to line up the numbers. So I have 0, 0, 0, 8, 5, 1. So then we just go down the line. These are the same, these are the same, these are the same. These are different, and 8 is more than the 0. Therefore, 8.51 times 10 to the negative 4th is greater than 6.3 times 10 to the negative 5. But again, if you recognize that 10 to the negative 4 is larger than 10 to the negative 5, because you have to think about how negatives are opposites of positives, then you could have noticed that. But if not, just expand and compare. And I hope this helps.